All right, Chapter 8, Semester 2, final review. So for 1 and 2, it says state the excluded values of each expression. Okay, so all we're doing is focusing on the excluded values. So we're looking at the denominator, just right here. That's all we're worried about, because you cannot have 0 in the denominator. So we don't have to worry about factoring this. We don't have to worry about canceling anything. All we're doing right here is looking at what x can't be. And you basically set this equal to 0. You can do it in your head or write it out. X equals -7, and then you put a slash through it because that's the one number x can't be. So if you plugged in -7 here, you'd have 0, and that's a no-no. Now over here, number 2, we do have to factor this. All right, a little guess and check. So the only way to get 2 is 2 times 1. And now we have some choices, 1 and 18, 2 and 9, 3 and 6. And we have to try some different numbers. Okay, so I'm going to try 2 and 9. We're trying to get 18 that differs by 5. So 2 times 9 is 18. And, sorry, that's 18. I'm losing my mind. Never mind. Okay, but here we have 18, and here we have 2, and that's going to give us 16. Okay, that's not going to work. So if I do the 9 here and the 2 here, that gives me 9. That gives me 4. 9 minus 5 is 4. That's what I need. Now, I need more positives. So I need this to be +9 and -4. Okay, so that's what the denominator factors to. All right, so we have the 18 from here. 9 times 2 is 18 there. And then the inside and the outside gives us the middle term. Now we just set these both equal to 0. So I'm going to do it in my head. Move the 9 over, -9, and divide by 2. So x can't be -9/2, and it can't be move the -2 over, +2. Multiply or divide each expression, factor and cancel. So here's where we got to start factoring everything. Okay? So number 3, we're going to factor the left top. X times x. We need 2 numbers that give you 4 that add up to 5. Well, our choices are 4 and 1 and 2 and 2. 2 and 2 adds up to 4. But 4 and 1 adds up to 5. And they're both going to be positive. Top right, we have a difference of squares. So that's going to be x plus 1, x minus 1. And on the bottom right, we have difference of squares, x plus 4, x minus 4. Okay? Now we can cancel. So we have an x plus 1 here and an x plus 1 here. We have an x plus 4 here and an x plus 4 here. And that's it. We have nothing left. On top, we have x plus 1, x minus 1. And on the bottom, we have an x minus 4. And that's all we can do. All right, on number 4, I'm going to factor out a 3 and an x. Okay, so 3x, 3x times x plus 5. On the top right, I can factor out a 2 only, x minus 5. Bottom left, I can take an 8 out, x plus 4. And over here, we have x plus 5, x minus 5, difference of squares. Now we start canceling. So x minus 5, x minus 5, x plus 5, x plus 5. This 2 can go into 8 4 times. So what's left? We have a 3x on the top. And on the bottom we have 4x plus 4. Now remember, we cannot cancel those x's. Okay, very common mistake. We can't do it. But we're done. If you wrote 4x plus 16 on the bottom, you'd also be correct. It doesn't really matter. It's up to you. But you can stop right there. All right. We have a division problem. Remember, we're going to turn this into multiplication. But when we do that, we have to flip the second fraction and only the second fraction. Okay? So I'm going to kind of factor and do everything as we go. So top left, I can take out an x squared. That's going to give me x minus 3. And remember, you can always double check, like send this back in. That's x cubed, and that's minus 3x squared. You can double check your work. Over here, we have 3, and then we have x plus 2. 3x plus 6. Now I'm going to turn this into multiplication, and I'm going to factor as I bring it down. So this is going to go on the top. This is going to go on the bottom. Okay? Now, before I do that, to make my life easier, I'm going to factor a 6 out of here. Okay? X squared minus 3x minus 10. That will make my factoring easier. Okay? And on the top here, I'm going to take an x out and get x squared minus 8x plus 15. Okay? That'll just make it a little bit easier when I factor. So, this 6 is going to be here. I'm going to factor it into 2 parentheses. X times x is x squared. I need 2 numbers that multiply give me 10 that differ by 3. Well, that's 5 and 2. I want more negatives, so minus 5 and plus 2. That's factored. All right. Bring the x down. Factor these into 2 parentheses. X times x is x squared. I need 2 numbers that multiply to give me 15 that add to 8. Well, that's 5 and 3. And since the middle number is negative, they're both going to be negative. That will still multiply to positive 15, but add to negative 8. Okay, everything's factored. Now the fun begins. But you also got to be careful because there's so much stuff that you don't lose anything in the canceling. So right here, the x minus 5s can cancel. X plus 2 can cancel. X minus 3 can cancel. Stuff's disappearing. Sometimes I like to clean it up a little bit, like right here. So I got 6x squared on the top, and I have 3x on the bottom. Okay? And then I can clean it up a little bit more. 3 goes into 6 2 times. This x will cancel with one of these. So I'm left with an answer of 2x. Final answer. All that mess up here simplified to just 2x. Kind of crazy. Okay, 6. On the top left, I'm going to factor a 3 out and get x plus 2. The bottom is the difference of squares, x plus 3, x minus 3. I'm going to turn this into times. Flip it. Again, this is going to go down here. So I'm going to pull 6x out, x plus 2. This is going to go here. I'm going to pull 4 out, x plus 3. And now I'm ready to start canceling. X plus 3, x plus 3, x plus 2, x plus 2. Now I can reduce the 3 and the 6 or the 4 and the 6. It doesn't matter. Okay? 3 goes into 6 2 times. Don't lose this x right here. Be careful. But then this 2 can go into this 4 2 times. Don't lose that. It's kind of messy. So what's left? On the top, the only thing that's left is a 2. On the bottom, I have this x and this x minus 3. If you wrote x squared minus 3x, you are correct, but there's no need to go that extra step. You can just leave it the way it is. Okay, 7 and 8 are just like 5 and 6. They are division problems. In fact, this could be written like this. And then notice, looks just like 5 above it. Okay, that's all that means. This is that division symbol right there. Okay, so I'm still going to end up doing this like I did on the previous problems. Okay, and if it helps you to rewrite it like this, to visualize it, go for it. Okay, just remember, if you do, this is going to go down here, and this is going to go down here on the top. Okay, so on the top left, I can pull out a 4x squared. That's the GCF. And that's just x plus 1 left. On the bottom, I can take out a 6x. And that's going to leave me x plus 1. And no, it's not, because that's what goes from the other problem. I'm losing my mind. Sorry about that. We'll get to that. I skipped right over the x squared minus 4. So we have a difference of squares here. X plus 2, x minus 2. This is why we double check our work. Silly mistakes. Okay, so I had it factored right, and I had on the bottom correct. It's just in the wrong place. So this ends up being 6x times x plus 1. And even though I made a mistake, mathematically it wouldn't make a difference. They're both on the bottom. But let's not go there. And then over here, we're just factoring this. Guess and check. X times x is x squared. We're looking for two numbers that multiply, give me 6, that add to 5. Well, that's 3 and 2. And the 5 is positive, so these are both positive. Okay? And now we start to have our fun. X plus 2, x plus 2. X plus 1, x plus 1. Okay? 2 goes into 4 2 times. 2 goes into 6 3 times. This x can cancel with one of those x's. I'm going to circle to make sure I don't lose this. So, what's left on top? I have a 2x. I have an x plus 3. On the bottom, I have a 3. And I have an x minus 2. And I just double check to make sure I didn't miss anything. And that's it. It can't cancel anymore. Okay, number 8. Again, if it helps you, you can do this. You don't have to. It's just whatever helps you understand and process it easier. Okay, so I'm going to turn this into multiplication. I'm going to factor the upper left, this one right here, x times x. Two numbers that multiply give me 40 that add to 13. Okay, that's going to be 5 and 8, and they're both positive. Okay, here we're doing two numbers that multiply give me 32 that differ by 4. Well, that's going to be 8 and 4. And I want more positives because I have 4 left over. So that's a positive 4 and a minus, positive 8 and a minus 4. That'll give me 8x minus 4x is positive 4x. Now remember, when I switch this, okay, the one with the 30 is going to go on the bottom, the 24 is going to go on the top. So two numbers to multiply give me 24. Oh, there was a typo on this. Sorry, and it doesn't make sense. This is supposed to be minus. There are no two numbers that multiply give me 24 that add to 2x. So, sorry about that. It was a typo. That should be minus 24, and that makes sense now. I need two numbers that multiply give me 24 that differ by 2. Well, that's easy. That's 6 and 4. 6 minus 4 is 2. And since this is positive, I want more positives than negatives. And then last but not least, two numbers that multiply give me 30 that add to 11. Well, that's going to be 6 and 5. Both positive. And now let the games begin. These x plus 6s, these x plus 8s, the x plus 5. Wait a minute, the x minus 4. Everything cancels. So is my answer 0? No, my answer is 1. When everything cancels, everything on top divided by everything on the bottom, anything divided by itself is 1. So this is a tricky one in the sense that sometimes people are like, oh, everything cancels, it's 0. That's not the case. Everything cancels. It's like if you would have had 5 over 5, most of us would not say, oh, it cancels. We would just say 5 divided by 5 is 1. But technically, you can say, oh, it cancels. And so therefore, it's 1. All right, add or subtract. We need to find a common denominator. Okay? So our LCD for this one, for 4 and 3 is going to be 12, and for x and x squared is going to be x squared. So I need to make this left one into 12x squared. How do I do that? I'm going to multiply by 3x, top and bottom. That will give me 12x squared on the bottom, which is what I need. And on the top, 7 times 3 is 21x. Second fraction, what do I need to make this 3 into 12? 4. And I already have the x squared, so that's all I need to do. But on top, you have a binomial. Make sure you put that in parentheses so you remember to write 4x plus 2 over 12x squared. Now I can add them together. I have 12x squared on the bottom. I have 21x plus 4x, I'm distributing, plus 8. 4x plus 8. And now I'm just going to join like terms. 21x plus 4x is 25x plus 8 over 12x. Fight the urge to cancel the x's. Fight the urge to cancel the 8 and the 12 by dividing by 4. You cannot do that because of the plus sign in the numerator. This is our answer. Except it should be squared. I don't know why I didn't write the squared. There we go, 12x squared. All right, first off, we need to factor the denominator over here. So this is going to be x plus 3, x minus 3. On the right, we have an x minus 3, so our LCD is simply x plus 3, x minus 3. My left fraction is already set up. It has everything I need. The right fraction is missing an x plus 3. Now remember, I'm going to be distributing this 4, so put in parentheses. And also, my hint, anytime you have subtraction, make it plus and assign the negative up here so you remember to send this in like this. So I'm going to do that before this time, just to show a different way. 8x minus 4x minus 12 over x plus 3x minus 3. (8x minus 4x is 4x minus 12 over x plus 3, x minus 3. But we're not done yet because I can take a 4 out of here and get x minus 3. And look what happens. I can do some more canceling and end up with 4 over x plus 3. You always want to check, can I do more? Is there more simplifying that can happen? Is there more canceling that could happen? All right. So over here on the bottom, we have 5 times x minus 6. And over here, we have 7 times x minus 6 after I factor it. So my LCD, I obviously need an x minus 6. And 5 and 7 gives me 35. Okay? So both of them have an x minus 6. So I'm good to go there. The only thing I need to do is multiply this left one times 7, top and bottom, and the right one by 5, top and bottom. Okay? So on the top, remember, I'm going to be distributing. I have 7x minus 28. This 5, I can think about it in front as a minus 5 because I change this like so. Just makes it a little easier to keep track of everything. So minus 5 times 5x is minus 25x. And minus 5 times negative 13 is plus 65. All over 35x minus 6. And then I'm just going to clean it up. 7x minus 25x is negative 18x. And negative 28 plus 65, or 65 minus 28 is plus 37, all over 35x minus 6. I do not have to distribute the 35. I'm good to go. The 18x plus 37 will negative 18x will not reduce because 37 is a prime number. So we're finished. That's all we can do. All right, 12. The only thing here you can do is say the LCD is x minus 9, x minus 1. That's it. So this one we need to multiply by x minus 1, and this one we need to multiply by x minus 9. Whatever we do to the top bottom, we must do to the top. Okay, which means we're going to be doing some foiling here. But the nice thing is, it's a difference of squares. So on the left side, we end up with x squared minus 1, because the inside and outside drop out. And then here, remember, I like to do this. So negative x times x is minus x squared. And negative x times negative 9 is plus 9. Well, look what happens. X squared minus x squared cancels. Oh, sorry, 9x. Negative x times negative 9 is positive 9x. So what's left on the top? Simply 9x minus 1. And on the bottom, we have our x minus 1, x minus 9. Remember, we cannot cancel the x's, we cannot cancel the 9's, we cannot cancel the 1's. We are finished. That's as far as it will go. Don't fall in the trap of starting to cancel stuff. We cannot cancel because of the binomials. All right, solve each rational expression. We don't want to have any denominators, okay? So what we're going to do is say, what is the common denominator? It's x plus 3, okay? And we're going to multiply everything times x plus 3. So x plus 3 times this first fraction, x plus 3 times the negative 5, and x plus 3 over here. What happens is the x plus 3 cancels here, leaving you just 2x. In the middle, we have a negative 5 times the parentheses, x plus 3, so that's negative 5x minus 15. We have our equal sign, and this cancels. And we're left with 1. And now we have a basic algebraic problem. Negative 3x minus 15 equals 1. Add 15 to both sides. Negative 3x equals 16. Divide by negative 3. And I get negative 16 over 3. Wait a minute, my answer is a fraction. That can't be right. Yes, it is. It's okay. And just to think, for extraneous solutions, the one thing it could not be, x could not be negative 3. Because that would make it 0. We did not get negative 3 for an answer, so we are good to go. All right. In a simple one like this on 14, we're literally just cross multiplying. So 6 times x plus 8 equals 5 times x minus 3. Okay. Technically, we're multiplying both by x plus 8, x minus 3, the LCD. And then the x plus 8s cancel, and the x minus 3s cancel, and we're left with this. Okay. So we end up with 6x plus 48 equals 5x minus 15. I want to subtract 5x, and I'm going to subtract 48. So that gives me 1x on the left side, and negative 48 and negative 15 is negative 63. Okay. The two answers I could not have would be x cannot be negative 8 or positive 3. I definitely did not get that, so no extraneous solutions. Okay, this one, x can't be negative 1. All right. My LCD is 3 times x plus 1. So I need to multiply everything by 3x plus 1. It's hard to do here. 3x plus 1, 3x plus 1, and 3x plus 1. Okay? On the left side, the x plus 1's cancel, leaving me 3 times 3x. In the middle, the 3's cancel, leaving me 2 and the x plus 1. And on the right side, there's nothing on the bottom, so 3 times 3 is 9 and x plus 1. So what I end up with is 9x plus 2x plus 2 equals 9x plus 9. That gives me 11x plus 2 equals 9x plus 9. I'm going to subtract 9x. I'm going to subtract 2. That's going to give me 2x equals 7. X equals 7 over 2. Fractions are okay. I did not get negative 1, so I have no extraneous answer. All right, last one. First off, this factors to x plus 2x minus 2, which conveniently are what these are. So my LCD is just that. So I just multiply everything times x plus 2x minus 2. Okay? So if I do that, it gets a little hairy here. All right, on the far left, the x plus 2 cancels, leaving me the 4 and the x minus 2. In the middle, the x minus 2's cancel, leaving me the plus 2 and the x plus 2. On the right side, both of them cancel, leaving me just a 2. Now remember, I cannot get 2 or negative 2 for an answer. That would be extraneous. So what I have when I distribute, 4x minus 8 plus 2x plus 4 equals 2. I join like terms. 4x plus 2x is 6x. Negative 8 plus 4 is negative 4 equals 2. Add 4 to both sides. I get 6x equals 6. Divide by 6. X is 1. No fraction. Doesn't matter. Not 2 or negative 2, so I'm good to go.